Welcome to the ADAS Empowered podcast. This is the show where collision repair professionals, calibration techs, insurers, and OEMs come together to stay ahead of the curve. Each episode, we'll dive into the latest in advanced driver assistance systems, exploring emerging technologies, calibration best practices, and evolving industry standards. Whether you're in the shop, in the field, or in the boardroom, this is the go-to source for thought leadership, collaboration, and real-world insights to drive safer and more efficient repairs. Let's get empowered together. All right, welcome to the premier podcast for the ADAS Empowered community. My name is Joel Adcock. I'm the Director of Partnerships with Rev, and I will be hosting today's conversation. Good colleague of mine, Ron Racine. Ron has had many years of industry experience. I'm humbled that he's accepted the invitation to join us today to talk about a lot of different topics that are ADAS related and repair related. But um, really quick, we will be launching a series of podcasts throughout the next few months with different individuals joining us as guests that have any number of different experiences or backgrounds, and mainly reflective on education opportunities to continue to develop network and resources for helping us all in the repair space and as it relates to ADAS. So really quickly on an introduction for Ron, he's been a voice in the collision and ADAS industry for many years, as I mentioned. He's got decades of hands-on experience, brings a rare combination of deep technical expertise, and operational insight, and a passion for proper repairs, which I think is critical. Whether it's ADAS calibrations, shop efficiency, or technician training, Ron's perspective is grounded in real-world application and experience, and a commitment to doing things what are correct. So, without further ado, Ron, thank you again. I appreciate it. If you could, feel free to give us a couple minute introduction. And again, thank you for being a part of this.
Yeah, thank you, Joel. So, as you said, I've been in the industry for quite some time, right? I started back in the mid 80s, and my first job in the industry was for a company out of St. Louis called Hunter Engineering. And I worked in Canada as their national instructor, where I delivered wheel service classes in both French and English across Canada for passenger cars, light duty trucks, heavy duty trucks, commercial vehicles, military, things like that. Then I moved to Mesa, Arizona to join a company called Shimco International, and we made aftermarket wheel alignment correction devices, so full contact shims, eccentric bushings, things like that. And then I joined FMC, so in Conway, Arkansas, and I joined their wheel service division in March of 1995. And then FMC was purchased by Snap-on in April of either 95 or 96, but I believe it's 95. And I spent 26 years there in various positions, but the last 17 years was technical training manager for North and Latin America. So again, was tied into wheel service, vehicle dynamics and wheel service. I retired from Snap-on in June of 21 and joined a company called Rivian in June of 21. So I had like a 4-day retirement period. And there at Rivian, I was the technical trainer for the commercial side, so the EDV, the Amazon delivery van. And there I did all the teaching on the wheel alignment, the high voltage battery replacement, maintenance, vehicle dynamics, so the ADAS systems, the stereoscopic vision, and all the things that were pertinent to that van. So I trained a lot of technicians in Costa Mesa, in Dallas, up in Plymouth, all over the place, Palo Alto. So they had us fly in and out and do all these trainings with these technicians on these new systems. I also inaugurated the training in Germany for Rivian and kickstarted the college. It's called Collins College in Dallas, Texas, where they do have a Rivian technician training program, sort of like a P-Tech or the Honda training system. So, like I said, I've been around, I hate to say it, almost 50 years in the industry. And yeah, in various positions for various companies. And the awkward thing I find in this industry is there's just a few of us, and we kind of gravitate and rotate, and we just move from one place to the next. I retired from Rivian in April of 24, and I started a company called Technical Training Developers. And what we do is we do all kinds of technical training classes for the automotive industry for various companies. Anything from mechanical lifts to ADAS training to programming, things like that. As long as it's pertinent to wheel service and vehicle dynamics, that's what we specialize in.
Awesome. I appreciate it. I think having that perspective of your background certainly helps with understanding the years of experience that you have, but more importantly, just your compassion or your passion for proper repairs, your understanding of vehicle dynamics, ADAS systems, and I think the overarching part of that being safety. And leading up to this podcast, we had some conversations around a lot of different things that were related to what I think we're both interested in, and that's obviously overcoming the myriad of challenges that we face in this industry, and there's no shortage of them, right? Between shops trying to stay busy, they're trying to train their team and their staff, and they're trying to making sure they've got the proper information and resources, and all of a sudden now the last 5, 6 years, 8 years or so, this term, this ADAS, has really become part of, like, really almost every vehicle that comes into a shop nowadays, whether shops want to believe it or not. And it's not just from extensive collision damage. It's on, practical everyday, even maintenance nowadays. So I guess, kind of leaning into what we talked about leading up to this, and, kind of formalizing some different ideas around this conversation that I think are really important. I'd love to get your thoughts on what you've experienced and what you see out over sort of the horizon of the industry as some of the biggest challenges, um, coming into this point of where we're at now, and what you've seen in the past, and where do you think those challenges will still continue to exist unless we do certain things to change and mitigate things. But I'd love to get your perspective on that.
I mean, these are great times, right? And this ADAS is a great addition to the automotive industry. It will help, drivers become better drivers. It opens up a whole new line of possibilities as well, where you could have full autonomous vehicles. But to get there, we have to start. So right now, here's how I categorize it. We're in the OBD1 of ADAS. So brief history, right? The ADAS started back in approximately 1995. I believe the Mitsubishi Diamante was the first vehicle to use autonomous cruise control. And awkwardly enough, it was made in Normal, Illinois at the current Rivian plant. That's how I know where that came from. And then
Life
Mercedes
comes full
came in 1995 with their Distronic system. And then by the year 2000, most manufacturers had some form of driver assist system, whether it was ABS or traction control or electronic stability programs and things like that, to help the driver negotiate circumstances where he may not be able to do it by himself. So the systems in the car would kick in and assist the driver. So it's been 25 years at least, right? Fast forward to 2012 is when we started seeing more and more and more of these systems being integrated in the vehicle. And the reason for that is, let me put this slide up there. It's this guy right here. So when NVIDIA, when they came out with this Orin chip, this is a very powerful chip, by the way. It does 254 trillion operations per second. So, I mean, it's limitless. It's a system on a chip. So it allows devices to acquire the data, process the data, apply the logic and determine the course of action, what to do once you analyze that data, and then they'll send a message to the actuator. So this chip was really a turning point in the ADAS industry. And some systems actually use two of these chips in the vehicle. So they can process a lot of data. The challenge that I'm seeing right now is the rate at which the technology moves, I believe, is faster than what the technicians can actually handle. So there's a huge gap in technology between the current knowledge and what needs to be known in order to perform the task successfully every time. You have to remember manufacturers build around 600 vehicles per day. They calibrate 600 vehicles per day successfully. And then you'll have a technician attempting to calibrate a vehicle, and he's going to spend 4 or 5 hours and may or may not get it done correctly. And there are reasons for that. And we're going to talk about that as we go through this presentation. But I wanted to show that chip because that is the game changer in the industry. And there are a couple of more chips coming out with AI possibilities that will allow us to move forward to the fifth level, right? To the full autonomous vehicle. And there are autonomous vehicles out there, like the Waymo car, that's full autonomous, robo taxis. Um, my grandfather's, what do they call those big tractors? That was fully automated. Combine. You do one pass,
Fine,
you
yeah.
flip it around, and then it just drives by itself for the rest of the field.
Right.
So,
GPS coordinates. Yeah.
but that's what happened. I just want to, and then we take for granted that these systems are simple. So somebody says, well, ADAS seems to be a really good business, so I'm going to buy all the equipment. I'm going to go out on the road and do calibrations. Well, it may be possible, but in some cases we have to understand what we're dealing with. This is an example of an architecture from an ADAS vehicle, a fully equipped semi-autonomous vehicle. This one has like 10 cameras. You see there's two orange chips right here in the middle, Orin A and Orin B. There's a cold plate, so it needs cooling because it generates so much heat that you have to cool those chips, right? They process a lot of data. For example, if you have an 8 megapixel forward-facing camera taking 30 frames per second, it has to process 30 times 8 million pixels. That's 288 million pixels in 30 seconds. Per second, pardon me, 30 frames per second. That's a lot of data that's coming in. So we need these kinds of chips. So we're there. We're at the end of the OBD1 for ADAS phase. Now they're going to start shifting into the OBD2. So we had a period of about 20 years to get the technicians up to speed, understanding the systems, kind of figuring out, how to do the calibrations, where to put the targets, and all this good stuff that's normally associated with these calibrations. But as you can see, it's a fairly complex system.
I've heard about the chip power, like NVIDIA's and things like that. That I've heard of even recently, where they're talking about like chips on top of chips to add additional, I guess, computing processing. Which, and you talk about the levels of ADAS from 0 to 5 being fully autonomous self-driving vehicles, and depending on who you talk to, we're kind of in that between level 2, level 3, which some autonomy, semi-autonomous. And as that chip computing power, the AIs, the multi or the machine learning, I guess, of the MLs and the sensor fusions and things like that. I mean, those are what we've talked about in some other webinars in the past, like stepping stones to getting to fully autonomous vehicles. Like how, before we kind of get into that next topic, Ron, like where do you see that in the future as far as like a timeline of like where we'll be at to a level 5, where those are majority of the cars that we see on the road? Is that anywhere in the next 5 to 10 years, or is it beyond that, you think?
Well, I believe it's well within the next 10 years. The major impediment there is there will always be some vehicles on the road that do not have the system. Or, you can't
Your
avoid a
tractors, right?
vehicle. Yeah, you got older cars out
Yeah.
there and they don't have any of these systems, so they can't talk vehicle to vehicle, and that becomes a problem. But as the vehicle base changes and these systems are now integrated in the vehicles and more vehicles have them, they can go to vehicle communication, and that will definitely improve the ability to do full autonomous vehicles.
Yeah. Yeah, I was at the ADAS symposium last week in Detroit, and they were talking about like the current age of vehicles on the road, and I believe it's like 12 years, which is incredible when you think about 12 years ago, some of the technology that's on vehicles nowadays that you find didn't exist. So, our drivers potentially putting themselves behind the 8 ball safety because of the fact that their vehicle may not necessarily respond a certain way. But again, that's a whole other topic of conversation. But it's very interesting as far as the computing power and what's on the cars nowadays in terms of processing information and capturing all that information from multiple angles of cameras and things like that. So what are your thoughts as we gonna kind of talk about like those challenges, but like some of the top misconceptions that you see shops or technicians having at ADAS calibrations today? I know you mentioned like a vehicle manufacturer, they'll build 600 cars a day. They've got a dedicated area where they're doing post um manufacturing calibration to make sure everything is aligned correctly. You think about like your average shop today, or even sublet companies that are doing calibrations on behalf of shops. What are some of those common misconceptions that you're hearing or seeing that maybe we can help those folks overcome at this particular point?
Yeah, I think the location is probably the biggest problem. Having the right location, the right environment, a controlled environment where you can prep the vehicle, and pre-scan the vehicle. First, you got to pre-scan that vehicle to make sure there's nothing in there that would prevent you from achieving the calibration, right? If you have a U code, or if there's a defective component, or a component hasn't been plugged in after a repair and you're trying to calibrate it, you're not going to be successful. So you have to pre-scan the vehicle, and then you have to precondition the vehicle. For example, air ride suspended vehicles like a Rivian R1T has to be placed in a specific ride height. It's called a design height, and that's the height the vehicle needs to be when you're doing the calibration. If you're not at that ride height, you will fail the calibration. So you may do everything right, but if you forget that step, it's going to fail. So they need to gather all that knowledge, right? So, and it's very different from vehicle to vehicle, although the systems basically and fundamentally all work the same way. When you look at a camera, how it works, a radar, how that works, the fusion of the data, how that works, the features created by those components linked together or fused together, they basically function the same way. What's different is the target size, the target position, the distance, the height, the split from the center line, one camera, two cameras, one target, three targets. So, there's really no general protocol on the equipment. So you have to be knowledgeable. And that's where information coming from your company or from Rev ADAS is really helpful. Which calibration do I need to do on this vehicle? And since the sensors are somewhat fused, or the information is fused, you may have to calibrate more than one sensor. So you may replace a windshield and say, well, I got to calibrate the forward-facing camera. Well, you may have to calibrate the forward-facing radar as well. It depends on the manufacturer and how they process that data.
Makes total sense. And what's interesting too is that the consistency between the OEMs is there's no consistency like with certain procedures as they relate to calibrations as far as like what you're doing to the car. There's certainly some overlap, but I think that's one of the frustrations that I know I've experienced in some previous roles working for different companies doing calibrations, and even now where there's no consistency to naming, there's no consistency to process. I think you bring up a really interesting piece around vehicle modifications, and this even came up last week at the conference I was at, where it's talking about like changes in tire size or changes in ride height or aftermarket modifications, and still being able to dial in a proper calibration and making sure you've got all the right information. Because if you put 30-inch tires with a 6-inch lift kit, I mean, it certainly changes the angle of like where a camera or radar is looking. So the example I saw was, the higher the the radar is up on the vehicle or in the air, essentially, that the narrow it would see the lines on the side of the road for like lane keep assist. And I think those are things that a lot of things the folks that just don't realize, right? That there is a huge amount of change that potentially could be as a result of those aftermarket modifications. So, um, how do you approach that vehicle complexity? Then, like, what's Ron's approach to like understanding those things? I know you've got a couple other slides that you wanted to share here too, but with modified or non OEM setups, I think it was kind of the next segue into like what we wanted to talk about here. So I'll turn it back
Yeah.
over to you.
So here's the deal. When you change the tire size, you're not only changing the height of the vehicle, you're changing the ground speed of the vehicle. So the
Right.
actual speed versus the speed detected by the wheels will be different. When they build a vehicle, they'll spec everything out, right? On the ADAS line, and I've worked at the ADAS station at Ribbons, I know how that works. They bring the vehicle in, they have rollers, they roll the vehicle, they center the vehicle in the lane. The targets are permanently mounted in the correct position. You push a button, you calibrate everything in about 2 minutes. All the sensors, everything get calibrated. Your 360 view, forward facing, the radar, everything just gets calibrated. It takes about 2 minutes. That's a perfectly controlled environment, right? They know there's no problem with the rear thrust. It just came off the alignment machine. The steering wheel is straight. The steering angle sensor is calibrated. The torque sensor is calibrated. They just center the vehicle and they calibrate it. Once that vehicle is gated, factory gated, once it comes out of that factory, if you modify the vehicle, the specifications for the calibrations do not apply anymore. Now, some manufacturer like Ram, I believe, will give you the opportunity to go in there and put offsets for the calibration specs. But if you raise the vehicle, your 360 view or your blind spot, everything, the angles will change and they won't respond like they should. The most dangerous one is the radar, because now the radar is a little higher, so its reach is a little further down the road, and it may not see objects close to the vehicle. So as far as modifications are on those kinds of vehicle, I really can't support that, because I wouldn't know how to go in there and change everything other than restoring the vehicle to its original gated specification, calibrating the vehicle. You're
I
going to
think
run into that
what's a
problem where this guy actually put bigger wheels on a Ford. Then the lights came on, so he went to calibrate it. He couldn't calibrate it. He went to the dealership, and the dealership says, "Well, we can't calibrate that, so you're going to have to restore it to its original spec. Then we can calibrate it." That's the kind of
yeah.
things we're going to run into.
What's obviously the best standard process in that instance is to get it back to factory spec as far as ride height, tire size, all those things. I mean, what are some of the options? Like if that's not an option, let's just say, for example, I bring my vehicle in to a local, tire and alignment location. I want to just put some new tires on it. I've already got big tires on the car to begin with, and now all of a sudden I'm just replacing them with the same size. I've got a forward-facing camera or radar. I do an alignment. Um, by virtue of doing that alignment, it may trigger a calibration, more than likely does, but it's not necessarily going to be prudent because of the fact that there have been adjustments made. I mean, in that situation, if not getting it back to OEM spec is an option, like, I mean, what do we do at that particular point? Can you provide any insight into that, or what I think, because that's a common theme or question that may come up in the audience.
Well, I mean, it places everybody in a precarious situation, right? If something should happen and the system did not react correctly or did not perform as intended by the manufacturer, the saving grace here is, when you're in a panic situation, you really don't know what's going on, and these systems will kick in and start applying the left rear brake or the right front brake and start to stop the vehicle to try to regain control of that vehicle even before you probably know what's going on. It happens really quickly. But if a vehicle underperforms, and they can find a way of saying, well, yeah, the system didn't work and didn't prevent me from hitting this vehicle or hitting this pedestrian or cyclist. They can go back and look at the data and they'll look at the vehicle and say, well, it's a modified vehicle. So the manufacturer will say, that's not our vehicle, that's your vehicle. That's why I'm really
Okay.
cautious about modification.
Yeah. Yeah. I think awareness is first and foremost the most important piece of all of this, is understanding that if modifications have been made, that things may not necessarily work as initially designed when the vehicle left the facility where it was manufactured. So, um, I wanted to talk a little bit too about, or we talked a little bit about this in sort of our initial conversations about, you talked about like the appropriate environment. I know this is a hot topic of consideration. Um, specifically on static calibrations, but then on dynamic calibrations as well. I live here in the Midwest. We have a propensity to get snow in the wintertime, and certain vehicles during the dynamic calibration are performing certain maneuvers based on seeing painted lines in the road. Um, Let's chat a little bit about that. What are some of your designs as far as I know you've got maybe some slides you wanted to share here, and if not, not a problem at all. But sort
Yeah,
of
let me
like
flip
what does an appropriate environment look like, and what is one that may not necessarily be conducive to doing a proper calibration?
flip back to these slides here. This is a video of a 2019 forward-facing camera. And this is how it acquires the data. So it'll see the object. It doesn't know what it's looking at, right? So it's all the software behind that camera. The camera is basically a light sensor or
Yeah.
an imaging sensor, and it can only detect light. The software will say, well, that's a truck. And once when we go past it, it'll change to a train, I believe. Yes, it's longer. It looks like a train now. It's not a truck anymore. This is 2019. There's not a whole lot of data coming out of there because the processors that we're using were not the NVIDIA in this case. I'll move to the next slide. This is a Tesla. Now look, this is only like 5 years later. And look at the difference. You get a lot more data. It's showing you the calibration for your pitch, your yaw, your roll. So the vehicle attitude is always monitored by the system. Corrections are made based on the proximity of objects, the speed of object, the speed of the vehicle, and the attitude of that vehicle as well. It can recognize more lines. You can see the cars. It sees things that we don't even see. We have to stop the video to see all the objects, but this camera captures all those objects and processes that data immediately. It knows if it's raining, if there's water on the street, if there's a splash, and things like that. This is only 5 years. Now, I don't have a recent video, but I wish I could find a more recent video. It's got to be a lot better than this because the cameras are different, the processing speed is even better, and the algorithms are getting better. These cars, they have a lot of AI. They learn, auto learn, so they have these deep learning functions, and they can understand the environment and make decisions based on the environment. So this would be like a
This is
level
yeah,
2.5, level 3 vehicle. So to achieve
this
this
is really
type of technology requires certain steps to be taken when preparing the vehicle for this. So the wheel alignment is critical. That's static. So you're statically predicting that if you set the vehicle up this way dynamically, it shouldn't change, and your direction will be the same. Your dynamic direction will be the same as your static direction. So I'm a strong proponent of static calibration because I'm in control of every step for that vehicle. Oh, there's your question.
no, you're good. You're good.
So this is a little
That video
different.
is amazing.
This is a
Yeah.
Rivian. So the Rivian has an adjustable suspension similar to like a Land Rover, for example, where you can set different height, sport mode, your conventional mode, then you have the off-road mode. So the suspension goes up and down pretty close to 8.5 inches on this vehicle, which means that your camera and your radar, your sensors are going to travel up and down that position, right? Well, when you calibrate this vehicle, you put it in the design height, which is a certain predetermined height. And then when you move it up and down, the offsets are included in the software to compensate for the height. So the manufacturer has already taken care of this part. This is what I would see in the aftermarket industry later on, is if the manufacturers can give a range and say, okay, so this is a Honda Civic. This guy most likely might lower the vehicle. So here's how much you can lower it. And if you do that, input that in the system, and we'll use that offset, because when you calibrate a vehicle, a lot of people are under the impression that they are changing dimensions or specifications. You're not changing anything when you're calibrating. Those numbers are burnt in there at the factory and they won't change. The engineers will not let an automotive technician go in there and change the parameters that affect how the system works dynamically. But you can put offsets.
Interesting. And I mean, again, just to define what a calibration is, I mean, you're essentially just ensuring that those sensors, radars, cameras, modules are within factory spec, looking at the appropriate space out in front of the vehicle at a desired length or target away, and ensuring that they meet those requirements based on what the OEM initially inputted as far as their specs go and things like
All
that.
right.
So I
Yeah,
think,
it's
again,
kind of
that's
an
another,
ambiguous term, right? Calibration means that you're going to
it,
identify the
yeah,
position of an object based on the known position of another object. So in this case, the known position are the targets. So you're going to position the targets at a certain distance, height, and split from the center line of that vehicle. Then you're going to hit calibrate. That will turn a routine on in the chip, in the ECU, and that routine will go out and seek the target. Then when it finds the targets, it'll identify and say, yes, those are the correct targets. I recognize those targets. And if they're in the right position based on the template digitally created in the software, it'll say yes, the camera is in the right location. We're not calibrating the targets. We're trying to identify the position of the forward-facing camera, for example. So if that camera's off by 1 degree, those targets are going to be off by a huge amount. So basically, that's what you're doing. You're confirming the position of either the camera or the radar or the object on the vehicle using targets in a known position. And that's the reason why I say when you're doing calibration, it's best to have a controlled area where your floor is relatively level. You don't have a couple of inches difference between the front slab and the rear slab, and the cars are in different location. Doing it outside sometimes doesn't work because when you turn on, in some manufacturers, when you go into the calibration mode, they remove the light filters. So the camera just gets a raw image and there's no filter there. So if you're outside, the infrared light may saturate the camera and then it may fail the calibration.
I think that's great to know because, unfortunately, I think there are folks that don't necessarily understand the importance of the controlled environment. And knowing that, I think alone speaks volumes that what the OEMs are doing in terms of light filtration and things like that. So I think that's incredibly important, which I think is it's kind of a really good segue into, um, understanding vehicle dynamics, understanding the OEM's position on, developing the technology, how they, calibrate a vehicle, post manufacturing. Now we've talked about like some of the misconceptions of, the ADAS industry and things like that. But, getting into like actual technicians and like working with them, training them, helping them understand a lot of these variables and things like that. I mean, you've worked with several technicians throughout your years and trained countless techs. Um, what's been your experience as far as identifying a good technician, somebody who really understands things versus one that, somebody that's coming into the industry that's relatively new and maybe doesn't have a lot of experience? What separates sort of those folks?
That's a really good question. Finding a good tech, a good tech is all about, I would have to say, character first. Got to have the right character, the right mindset. Not be a mechanic, to be a technician, to have the ability to make an observation, logically reason what's going on and why, that the cause, finding the root cause, and then giving a long-term cost-efficient solution to that root cause without jumping any steps. I can go back to in the early days of the O2 sensors. Anytime you had an O2 code, the sensor was bad. Well, that was not always the case, especially if you work on JAGs, the air bellow underneath the throttle body. So, but it's an O2 code, it's the O2 sensor. Well, you can't have that mindset with ADAS because these systems actually intervene on behalf of the driver. So when you're working on an ADAS type vehicle, you really need a technician, a person that can slow down and say, okay, what did the customer say? What's the observation? Give an example on Rivian's delivery vans. The driver's up in New York, they may hit a snowbank. It happens. They'll slide and hit a snowbank, and it'll hit the bumper, pushes the bumper in. Right behind the bumper there, you have a side-facing radar. So it'll bend the bracket. They won't complain of anything except this. It's kind of weird, they'll say, I noticed recently that the cars are like a lot further up close to the vehicle before I get a notification. Now, there you go. So when you bring that into a technician, he has to have the ability to understand, or I guess I know what happens, and go in and check the bracket, replace the bracket if necessary. In some cases, you may even have to replace the radar. There may not be any apparent damage to the bumper, but it just flexed enough to damage the component. So yeah, the technicians, and they have to have the ability to learn and the will and the want to continuously learn because it's changing really, really fast.
Really fast. Yeah. Yeah. I think that's probably the most important piece that I've seen and I've experienced too is, like you mentioned, uh, having the technical aptitude, uh, continuing to learn, developing the changes or monitoring things as they continue to change and the adaptability and things like that. I think all too often a lot of folks get into this thinking that there's going to be a mad rush to like some sort of success. And while I can applaud their ambition, I think there are certain steps that need to be taken into job shadowing, connecting yourself with somebody who has a lot of experience, understanding that there are going to be times where you run into issues and you're going to need to reach out to a resource or somebody for support, or a group of folks or whomever that might be, that we're all kind of working on the same things together, right? We're trying to get to the same spot collectively to put cars back on the road that are safe. Because I've got a family, I know you've got a family, other people have got people on the road that they're concerned about. We want to make sure everything's done correctly and safe. So I think adding all of these things up in terms of understanding the technology, having the correct environment, proper environment, uh, understanding that there are resources out there when we get hung up on, why did this calibration fail, or why can't I seem to get this car back on the road safe? Um, it falls back into that, right? It's really imperative that there's this sort of this continuous circle of opportunity. And I think having conversations like this certainly helps.
You know, I was talking to Jim from ADAS of Texas the other day, and he said something that really stuck with me. He told me he used to spend 30 minutes to an hour researching repair procedures, just trying to make sure he wasn't missing anything the vehicle actually needed. Then he started using Rev, and that time went down to nearly zero. Think about that, an hour of research down to instant results. If you're in collision repair or ADAS calibration and you're still doing things the hard way, it might be worth checking out Rev at revhq.com. That's REVVHQ.com to see what Jim's talking about.
So when you think about like a skill set or certification, what does that look like, and what should every tech be working towards as they continue to develop their skill sets? And is there a certification available for ADAS technicians currently that you're aware of, Ron?
Not that I'm aware of that would be any of any significance, right? There are companies out there that do offer uh, ADAS training in a way and the sort, but to have a proper certification, I believe the technicians would need to learn and understand how the system works. Positioning targets and pushing buttons on a scan tool to do the calibration, that's easy. That's the easy part. It's when it fails that's the hard part. Why did it fail? And listening to a technician tell me, well, I had to move the targets about 50 millimeters to get it to pass. Well, if you're moving the targets to get it to pass, that's defeating the calibration. That's telling me that the camera is not in the right location or the radar is not in the right location. And having to move objects, your calibration objects around to pass the calibration, that's defeating the calibration. That's because they don't understand how the system works. And that training is not readily available for everyone. Here at ADAS-UE, we do that. We'll get into that to that depth. Here's how a camera works. Here's how the calibration works. This is how the data is acquired, processed. Here's the speed at which it's processed. And here's why those targets are at this size, and you're going to have to put it at that distance and the height and the split. We go through all of that. Same with the radar and any other LiDAR or any other devices on that vehicle. We explain the why, the purpose, in hopes not to have people move things around until they hit the button until it passes. That's just not right. Or you'll have a technician, work a couple hours on the vehicle, do a static calibration, then he goes out for a dynamic calibration, which you have to ask yourself, why would I have to do a dynamic after I did a static? So it passes the static, then you go do a dynamic. The question is, why do I have to do that? Well, here's the answer. That's because the OEM, the manufacturer, doesn't trust the technicians in doing the jobs correctly to begin with. They know they might move the targets around to get it to pass. So do a static, then go drive it. That's validating your static calibration. And if it fails, you missed a step somewhere, or the target was moved, or the vehicle dynamically is different than statically when it's moving. So when the vehicle begins to move, if you have a thrust angle at the rear, obviously the rear wheels will dictate the straight ahead direction the vehicle will follow. The front wheel steer in that direction. The vehicle is now dog tracking slightly. So your dynamic trajectory is different than your static trajectory. And that will make the vehicle fail. So you missed a step. You didn't do the alignment because you think that the alignment is not necessary. But we don't have to do that. So the only important part of the wheel alignment for calibration, and I used to tell this to the technicians at Rivian, is the rear thrust angle. If the thrust angle is within the OEM spec, calibrate the vehicle. If there's a bad camber angle at the front that you need to correct, align that after if you want to. But if that rear thrust angle is not within OEM spec, put it on the alignment rack and align it first, then calibrate it.
And do your calibration. Yeah, makes sense. It's incredibly important, right? I mean, there's so many things to have to consider, and as a newer technician coming into this industry, I think it's critical to have that level of knowledge and then work towards, like we talked about previously, in terms of that continuous learning. And I think you bring up some really interesting points as far as like understanding like what to do when a calibration fails and understanding importance of center line as it relates to alignment and things like that. So, um, switching gears here a little bit, we talk about the ability to bring technicians in, make sure they're trained, make sure they've got the proper skill sets and things like that. And there's a considerable amount of, I think, shops that are investigating whether or not to bring certain amount of calibrations in house, not necessarily 100%, but maybe just a percentage of the ones that they do. But if you were a shop owner, what would be some things that you would focus on in terms of creating a culture that fosters continuous learning around diagnostics and ADAS? Like, what would your mantra be as far as like how you would sort of preach that level of culture as far as it relates to those things, Ron?
Yeah, great question. Well, what I would do is I would definitely have a process. When a vehicle shows up for calibration, I would definitely have a process. That vehicle, I would have a dedicated person to bring the vehicle in, inspect the vehicle, check the tire wear, check the tread depth, make sure it's got the right tires on there, right wheel size, unload the vehicle if it's loaded, scan the vehicle, and also prepare, precondition, and analyze that vehicle before I give it to the calibration tech. And I would use imaging equipment. So in the industry right now, there's 3 different types of equipment for doing calibration. So you have mechanical centerline equipment, which will make you use either a laser or plumb bobs to find the center point at the rear, the center point at the front, and you pull a line between the two, and then you measure off of that and kind of position your targets based on the mechanical center line of the vehicle, which is the body center line. Then you have rear wheel reference equipment, which will put targets on the rear wheels and kind of figure out where the split is, in between the two wheels. That's not thrust angle. That's just rear wheel reference. And then you'll have the thrust line reference equipment, which is the imaging equipment like the John Bean True Point or the I-900, for example, from Autel. Those actually reference the vehicle based off the 4 wheels, because the wheels are what actually move the vehicle, right? So you're going to get the geometric center line of all 4 wheels, which it may not be the geometric center line of the vehicle, but it's the geometric center line that is put together by the alignment machine or your ADAS machine when you do your compensation. So it'll find the center of the vehicle. It's going to look at the rear toe, figure out what the thrust angle is, and then it'll position those targets based on that thrust angle. So you can't go wrong and you can't move them. So once you position the targets, if it fails the calibration and you move the fixture to the left or the right to try to recalibrate it, that won't work. It's going to make you bring it back to its original position. So that eliminates that possibility of a technician just moving the targets to make it pass. I would definitely have that type of equipment, imaging equipment.
I think that's important too, is from that culture standpoint of shifting the narrative within the shop that we should be looking at every car and trying to figure out, calibration should be part of our lexicon, our daily verbiage, the things that we think about as we look at process of repairs. I mean, if you're not calibrating a vehicle nowadays, there should be a checklist as to why you're not calibrating. Like you should changing that shift and that narrative and that mindset of like, we're not necessarily just looking to calibrate when we need to calibrate. We should be looking at every vehicle and assuming we're going to calibrate. Would you say that's maybe a better overarching concept of like how production managers, service writers, estimators, shop owners should be looking at vehicles and technology nowadays?
Definitely, yes, for sure. So you would need to have the right technicians, right? A process, a procedure, and a process to process those vehicles. You need the information, which vehicles require calibration, what type of calibration do they require? Do I have to do an alignment, a wheel alignment first? If we look at the German cars, for example, the Volkswagens, the Audis, those vehicles, if you follow the OEM procedure, that vehicle will be on an alignment machine. It needs to be on a controlled surface, which normally is the alignment rack. And they've been doing this since 2000, for 25 years. They had it right back in 2020. A control surface, a control environment, the technicians in control of the whole job. But it's the information. So on an A7 with 3 forward-facing radar and a couple of cameras, when you bring it in, what do you have to calibrate there? Well, you're going to have to calibrate probably everything. So you need to have information where you can download that information and make it part of your estimate for that repair or that calibration, and make sure you cover everything and you have all the right steps.
Makes total sense. And I think there's a lot of conversation too around like, with what Rev does in terms of identifying, and there's obviously other platforms out there. Certainly not any one platform is 100% accurate. I mean, what would you suggest as far as some redundancies or additional processes in place in terms of validating that information? Because as much as I'd love to say like the company I represent is 100% accurate, I can't quite substantiate that, but I want to make sure that we emphasize that some additional research certainly may be the case in terms of validating appropriate information.
It's very difficult to have up-to-date information unless you're connected to the OEM. I mean, I was there. I know how many
Yeah.
times they changed the specifications on the Rivian vehicles for calibration. So by the time they make that change and they broadcast the change to the equipment manufacturer, the calibration equipment manufacturer, then the equipment manufacturer has to enter those new specifications into the software, and then they have to publish that. You're looking at 2 months, right? It can take a while. Unless you're connected to the OEM, you'll never get the up-to-date, up the today information. And in some cases, you go to calibrate a vehicle and you're using the same process that you've used last week on the same vehicle, and it may not work because the specs have changed. There's a new position, new location for the target. Based on on that deep learning, sometimes they have to change the specs because the vehicle is not reacting as intended by the engineers. If the specs are too tight, the vehicle will react too quickly, and sometimes it's abrupt, and the driver doesn't like that. It's like an intervention. It's like your passenger grabbing your steering wheel for you and turning the vehicle when you're not expecting it. So that the specs have to be a little bit wider to allow a little bit of lag time, but you can't have too much lag time. In some cases, emergency braking, for example, you're dealing in milliseconds. We as humans are used to dealing in seconds, minutes, and hours, right? But these systems, it's milliseconds. By the time they acquire the data and they process that data and make the decision, well, we're going to hit this car in about 1.2 seconds, apply the brakes, and hard. So, yeah, it's more complicated than we actually think because we don't
Yeah.
expose all of the systems, and the knowledge is a little bit fundamental, on target placement and all of this.
It's interesting. Yeah, I mean, because you and I talked a little bit about this, and this was something that we wanted to surface up was, when you talk about like OEM procedures and access to OEM information, and there's a multitude of different resources and utilities out there to try to understand like what you need to do and doing it in real time and being efficient and matching cycle time and all those things. But one of the things that we wanted to talk about was that relationship between OEM procedures and like real world shop application in terms of like how do you see that evolving? Because I think that's an important piece that we wanted to talk a little bit about too today.
I mean, at the OEM level or at the independent level?
Well, just sort of the relationship between like the independent level and the OEMs as far as those procedures and having the right information. Because like you say, there can be a bit of lag time there, and 2 months, there's a lot of repairs that can happen in 2 months at any independent shop. So how do you see that evolving as far as that relationship between those two entities?
Well, some OEMs offer the possibility to become certified to work on their vehicles, I would definitely explore that. Collision shops, for example, have to be Tesla certified or they have to be Rivian certified. If you can move in that direction, I would, because now you have access to OEM information. You're connected directly to the OEM. So all the service bulletins, all the updates, that all comes in. You know about that as they're made available.
Right. Yeah.
Other dealerships, I would, in my area, I would definitely talk to all my dealerships and say, hey, listen, I've got this shop, brick and mortar. We're doing calibration, have pictures, sell your sauce to the dealership. Say, we can help you. I know let's say you're a Honda dealer, but sometimes you might get different vehicles in here on the trade and that light might be on. I can certainly help you with that. I would for sure talk to those people in the body shop.
Make the right relationship with the right folks as far as like them having the information and being able to share and partner with them.
Yeah,
Because like I said
I've got the
before, it's like,
equipment. I've got I've got trained technicians. We have all of the sensors. For a one stop, we can do it all for you here.
so let's talk about tools. Because I think that's kind of a segue into this as well, as far as like if you don't have all the tools, or if you work with a sublet that's got, maybe a good mix of things that they can do. Outside of that, like, from your perspective, like what are your go-to tools or equipment that really every shop should have, and why should they have those?
Lately I've noticed that the tools are getting a lot better. So, I'll use some Snap-on scan tools. I'll use Autel, Top-Down, Aztec in some cases, Opus. So for remote programming, let's say I don't have access to the vehicle and I don't have the tool for that vehicle, you can always use a remote calibration or a remote service to do the calibration for you, to initiate the calibration. You're going to be paying that guy to connect to the vehicle and pushing the button. You're going to position the targets. That's your job. That in some cases that works really well. Or OEM, if you sign up on the OEM info, and you can use the OEM scan tools or use their remote programming capabilities. I would definitely do that. And as far as target placement, there's only one thing you need to use if you're going to get in the business, is buy an imaging system. That's what you need. Anything else, when you start using plumb bob, well, you don't really know if the emblem is in the middle of the vehicle. In some cases, they don't have an emblem in the back. Then the plumb bob is on the bumper and it's not really centering. Your center line is not correct. So, as you move forward and forward, you're just generating more and more and more error. Next thing you know, it won't calibrate and you're moving stuff around. It's just a pain. And you haven't checked the wheel alignment. So you do a static and it passes. Then you go do a dynamic and it fails. Or the other one I hear a lot also is like on Toyota, you have to move the targets into 3 different positions. So it got position 1, got position 2, but it didn't find position 3. That's not right. It did find it. But when the software stitches all 3 images together, that total image is incorrect. It's not the third one. It's all of them. They're just not in the right position.
Yeah. Yeah.
And
That's interesting. I mean,
if you have if you're going to be in the business for a while, setting up a flush mounted wheel alignment rack is also a great idea. You drive the vehicle, you bring your vehicle to your pre-calibration area. You inspect the vehicle, you precondition the vehicle, you scan that vehicle, you get it ready for the calibration, then you bring it, you park it on that wheel alignment surface, which is a controlled surface. Normally they're relatively level, and you have your calibration equipment in front of that. That takes a lot of the potential errors out of the procedure. I've been in a shop where the car and the calibration equipment was on 5 different slabs. And as you're moving things around, you could see the heights were different. Now, imaging systems like the TruePoint, for example, will position the height of the targets based on the contact patch of the tire and not where the stand is actually located. So you can't go wrong on the height. The height will be correct based on the car. On a mechanical system, you would know the difference in the floor, or if the floor is tilted, if there's an off level slightly, you would not know that. So, if you're going to be in the business and you want to do a lot of production, produce a lot of vehicles, yeah, you would need an imaging system is the best. And then you need the information system, so you don't step over an important step. Let's say you're doing an Audi A7, 3 radars, you got to do all 3 of them, but you say, well, I'm just going to do the the short distance radar, the emergency braking radar. Well, you have to calibrate the others because they share data. And if you don't know, well, one, you're going to be missing out on income, and that vehicle is probably going to come back.
Yeah, I would say the technology, the tools, they've rapidly advanced the last few years. I mean, from when I started in the industry 4 or 5 years ago, I mean, a lot of the times what we were seeing was tape measures, tape on the floor, plumb bobs, manual processes to find that appropriate place to position the static calibration stand and the target systems, whereas now obviously the sophistication of those equipments and tools have been morphed into more laser guided imaging processing, things like we were talking about to find those measurements more accurately and certainly in a faster, shorter period of time. So um, they're costly, certainly. I mean, there's an expense and an investment. What would you tell somebody as far as if they were looking at bringing something in-house in terms of doing their own ADAS, and maybe you've got somebody in mind to be a technician trainee? I'd love to hear, because I know you're the ADAS COE or Centers of Excellence down in Las Vegas. You guys do provide some training as far as uh, for ADAS and things like that. Tell us a little bit about what that group does, and like what could somebody expect if they did like your module-based training and training in person, if you could.
Yeah, so what we do is it's slightly different. When you buy the equipment, let's say you buy a True Point off of John Bean, for example, they will provide equipment training. So the guy will come in and show you how to use the machine. There's a
Right.
pretty good possibility that he won't know how to calibrate the vehicle. So you won't know your scan tool, or because it's independent of the scan tool, right? The True Point can work with any scan tool. If you have an Autel 900, for example, well, the scan tool is part of the deal. So you're going to use that scan tool to calibrate, and that instructor will train you on the machine and the scan tool. What we train on is the next step. And the next step actually should have been the first step, where you come to school and we'll look at a system. We'll take a forward-facing camera, for example, and we're going to go in and dissect how that system works, how that camera is positioned, and how it works in relationship with the vehicle. So we'll talk about vehicle dynamics, why it's important to set the vehicle at the correct design height. Make sure your wheel alignment, your rear thrust angle is within the OEM specification, and how you do that and how you correct it in some cases, right? We'll talk about tire wear. So we'll cover all the aspects of vehicle dynamics. So alignment, tires, vibration. We don't think about this, but wheel vibration, if it's bad enough, can actually change the frequency on some sensors that are utilized by the system to determine the vehicle speed. If the wheel bounces up and down, that frequency will change on that wheel. And in some cases, it even slows the vehicle down because it thinks that wheel is slipping. And that happens, where you have a lot of snow and you'll get a big patch of ice stuck in the wheel overnight or whatnot. Then you leave in the morning and it's got that big vibration. And it'll slow your vehicle down. So we cover all of that. Then we will go and explain, here's how the calibration works. Calibration is normally determining the position of an object based on the known position of another object. Okay, that's fine. But how does the computer know that's the right target? How does it know it's in the right position? And how does it know the camera's in the right position? So we'll talk about those relationships, and we'll show the templates, how the templates work. I mean, I've worked with some of the engineers at Rivian that they're from Siemens and NVIDIA, that actually do the programming for the calibration. So I understand that part. I was there and I understand that part really well, how that works and how the camera sees the targets and they have to be in a certain position. I get that. And the distance basically is for speed calibration, right? Along with the radar. So because a camera is not really good at determining the speed of an object, but it's pretty good at determining what the object is. The radar is better at determining the speed. Analog signal, no interruption, no conversion, and super fast. So we cover all of those, all that technology aspect, from the chips to the cameras to the communication, the CAN networks. We also talk about the fiber optics in some cases, or the cabling that connects for power and data from the ECU to the camera and how that works. How to determine if the camera is actually working just using a temperature gun and pointing it at the camera. If the camera is warm, there's power to it. If there's no data coming out of it, you have a data problem. It's a different problem. So we go through all of those various possibilities with the technicians. So when they leave, they have a really good understanding of how calibration works. And that enables them to be a little bit more efficient at following the steps in target positioning and setting up the vehicle. And they understand also if you modify that vehicle, all of this may not work anymore because the vehicle is sitting at a different height, different attitude. Yeah, that's, in a short sense, that's what we cover.
I love it. Yeah, it's great. I think that's the kind of training that's necessary, right? It's that full encompassing understanding of not just performing a forward-facing camera static calibration and off you go. It's really getting that full context of understanding like how all of these systems work, how all the things work together, patching all that information into understanding concepts and things like that. So I would encourage anybody out there that's listening, go to the ADAS COE website. I believe it's www.adascoe.com. Connect with Ron and his team out in Las Vegas. Again, I think they offer, I know they offer some module-based preparatory type training that gets you to the spot where you can go out and do their in-person training out in Vegas over a couple of days. So encourage anybody to look into that. So I think that kind of leads us into sort of the last couple of things here as we kind of wrap up, and I certainly appreciate all this information. I mean, we could probably sit and talk about this stuff. I know you could really all day long because I mean it's really never ending, and obviously you've got a wealth of knowledge and experience in this, so it goes without saying. Um, as far as you being sort of this collaborative voice in the industry, how can more shops and techs get involved with conversations with, as I talk about, like, we've got our community and we talk about thought leadership and we talk about education, and there's more vehicles out there that need calibration than there are technicians that are able to perform those calibrations, and we think of the sheer amount of just overall opportunity to ensure vehicle safety and maybe drive a little bit of revenue if that's part of it. What's your thought on that, Ron, as far as like how more shops and more techs can get involved in the conversations and be better constituents for the industry as a whole?
Well, the situation today is a lot better than it was, let's say, 10 years ago. You have more information available, you have more people that have been doing calibrations, and you have more cars with more systems, and those systems are not going to go away. Actually, I think we're going to have more systems as we move forward to more autonomous driving. They're probably going to drop some of the components that are on there and go to LiDAR base, like the Waymo, for example. So it's like the new tune-ups, right? Back in the old days, we used to do tune-ups on the engines. Now we don't do as many tune-ups, but ADAS is the new tune-up. Any changes to the suspension will affect how that system functions. Any repairs that weren't done correctly or not done thoroughly, for example, I should say, will affect how the system works. But today there's more like Rev ADAS. You have all that information available, which you probably didn't have 10 years ago, or you have to dig a lot for that information. You have better equipment, imaging systems that allow you to check the wheel alignment, as you're doing your compensation and set the targets based on the vehicle's position on the ground instead of where the stand is. So it eliminates a whole lot of errors, possible errors. It speeds up the process. So that's a lot better than it was. Better information, better equipment. There's better training as well. And there are companies there's a company up in Utah, I believe, ADAS Calibration. They do a great job, and they train a lot of people, and they do a fantastic job.
Car ADAS. Yeah, car ADAS.
Car
Yeah.
ADAS, yeah. So there's a lot of, it's changing. It's changing a lot. And for those that are out there doing calibration, they probably see the changes as well in the vehicle as they go from year to year to year. There's more information, so it's a lot easier. But you have to take the right steps. You're going to need an information system. You're going to need, top quality equipment. You're going to have to train your technicians. So you have to find the right character. I'll always hire character over paper because you can train character, and sometimes paper, you just can't train it, right? And you have to have a process and a procedure to handle those vehicles as they come in. But it's a lot easier today than it was 10 years ago.
Yeah. I would agree with that. I think There's a lot of resources now too. You've got a
Yes.
lot of different utilities and like, Car ADAS is a great example. They train a lot of folks and they follow things, to a certain protocol that they've identified, and they've even created some level of training with their partnership with iCar, I believe. I see a lot of things on social platforms of conversations and people asking for help, and there's Facebook groups, and there's Reddit threads, and there's, like we mentioned the ADOS Empowered community that we launched back in December, and we see daily activity of folks looking for help or questions, or how do we do this, or how do we solve that. And I'm not saying one is better than the other, but I think those are the types of things that if we can continue to aggregate those types of conversations and continue to funnel people to the right pieces of information, because all too often, you probably have seen this as well as I have, is that if somebody asks a question and maybe they just don't know any different of like how to perform a specific calibration, they get kind of bullied or pushed around, which I don't think there's necessarily any place for that at this point. It's like, we all have to be good stewards. Let's use every opportunity where we see opportunity to educate and inform versus like push somebody down. Because we all started at some point too. We all had a starting point, or a place where we didn't necessarily know what we know today back in the past. So I would encourage those that are listening, if you see an opportunity to educate somebody, take advantage of it. If you see somebody doing something that they don't know any different of being wrong, or improper, or maybe putting somebody in a unsafe vehicle, you don't necessarily need to call them out. It's just, let's do the right thing. Let's understand that we're all in this together, and we've all have sort of this shared vision of like putting cars that are back on the road safe and everything. I'll step back off of my soapbox on
Well,
that, but
I believe we have to be
I'm
more
very passionate
tolerant.
about it. I know you are too. Yeah.
We just have to be more tolerant. And the fact that the person is asking the question, although he may think, even the person asking the question may say, oh, this is a stupid question, but I got to ask, I don't know the answer. We should be more tolerant, and we should provide support for that individual, no matter what. It's not a question of I'm better than you are, or we can do it and you can't do it. He's asking the question, so be tolerant and answer the question correctly.
It's too easy to look at and say, well, you're doing it wrong, and we're going to call you out on it. It's like, it's more of, hey, let's just have a sidebar conversation, and maybe you just aren't aware of like some of these dynamics, and pardon the pun, but um like I said, I know there's a lot of different channels out there currently with a lot of different information. So let's wrap up with this. I mean, this has been fantastic. I know we probably went a little bit longer than we were initially planning, so I certainly appreciate your extra time. But I would say let's leave it with this. As far as, if you had 5 minutes with a shop owner, um, anywhere across the country, what's one message you'd want to share with them, Ron?
Well, first, I would thank them for their efforts, and I would commend them on their ambition, because if you go back 10 years ago, if they started 10 years ago, they would definitely understand where I'm coming from, thanking them for and commending them for the ambition, and just encourage them to continue to pursue the opportunity by investing in maybe better equipment or more equipment, information system, more learning, more people development. I try to stay away from the word training for this reason: is we train animals, but I think we develop people. And lastly, I would say, apply the pride of work, and that's something that I think has been lost. Since they've done away with the trade school, the pride of work and the dignity of work, it doesn't seem to be out there anymore. It's just a job, and it's just something I'm doing. Well, hold on. You're working on a vehicle that's got more technology than most of your spaceships that went to the moon back in the day, right? So it's a very complex thing, and it's something that if you're capable of working on that vehicle and taking care of those situations, you should be proud of that. You should do it with pride and dignity, and there's nothing wrong with the pride and dignity of work and integrity,
I
right?
think
Doing the right things
yeah,
when even no one's watching.
yep. I completely echo that sentiment of like, appreciate the hard work, appreciate the ambition from the folks that are doing this on a day-to-day basis. I've been doing this to some degree for 15 years. I know you've been doing it longer, and it can be a thankless industry sometimes. It can be extremely challenging. Uh, one day to the next can be completely different. and certainly one vehicle to the next. They're not necessarily all the same. So I applaud those that are doing things on a day-to-day basis as well. So this has been fantastic, Ron. I certainly appreciate your time, your unbelievable amount of depth of knowledge, industry experience. I would be behooved if I didn't ask for a second call or podcast with you at some point in the near future again to maybe elaborate on a few of these things that I know we could do deep dives on. But again, appreciate your time. Continued success in everything that you do in the industry. Goes without saying that it's your contribution to the industry should be applauded and thanked as well. I can't say that enough. So with that, we'll go ahead and close. And again, Ron Racine, ADAS COE, Centers of Excellence out in Las Vegas. Feel free to reach out to him on LinkedIn and ask any questions directly to him or myself from the end of the podcast here. And again, Ron, we appreciate your time, and I'm sure our paths will cross again very soon. Appreciate it, sir. Thank you very much.
You're welcome, and thank you for the opportunity.
You're welcome. Thank you, sir. Appreciate it.
ADAS isn't the future. It's already here. And if your shop isn't calibrated to handle calibrations, you're falling behind. Rev empowers shops to catch every required calibration, generate OEM compliant documentation, and recover revenue that used to slip through the cracks. Trusted by top performing shops across the country, Rev is the new standard. Don't wait. Schedule your demo now at revhq.com.